Welcome, everyone. Welcome. The name of the show is Achieving Great Health. My name is Bob McCauley, owner of the Watershed Wellness Center in Lansing, Michigan. Watershed.net is the website. Blog.watershed.net is the blog. Watershed 11 is a YouTube channel. I do appreciate you joining us. This is a show that discusses natural health and how you can be healthier than you ever imagined. Guest today, my special guest, is Dr. Gerald Pollack from the University of Washington. He is an expert in water. I'm going to let you give all his, he'll give you his credentials. He's got a brand new book out, and we're going to talk about that today. I just wanted to welcome you to the show. Dr. Pollack, thank you so much for joining us today.
Well, thanks so much, Bob. It's a great pleasure to be on with you and to chat with your listeners. Did you want me to describe my background, or?
Yeah, if you could real briefly. What? Absolutely, if you could do that, it'd be great.
Starting from birth.
Well, we just give the academic credentials.
Okay. Well, I'm a professor at the University of Washington, which is here in Seattle, and I'm also, since I've been deeply involved with water, I actually do a couple of other activities that are related. One of them is editing. I'm the editor-in-chief of a journal called Water. Mm-hmm. What else? Mm-hmm. It deals with the science of water, mostly experimental science. And also, I organize each year a series of meetings on water. Usually, it's been annually in Vermont in October. Nice time to be there. Mm-hmm. This year, it'll be in Bulgaria, near Sofia. Bulgaria is noted for its healing waters, and so it's actually a good place to be. And about 100 or so scientists and other people generally interested in water come to that meeting each year. And we have some prominent scientists, some younger scientists, people diversely interested in water, and the meetings are lively, interesting. This year we have a Nobel laureate, Luc Montagnier, who's going to be there and tell us about his really interesting experiments. So anyway, I've been at the University of Washington for some time, but these other activities make life extremely interesting.
Mm-hmm. Fantastic. So, and also, you just wrote a new book, and I'm very, very interested to take a look at it. I haven't seen it yet, but it's The Fourth Phase of Water, and this is what really caught my attention. And, I heard you in another interview, and that it kind of popped up on my radar. I'm a big water fan. My father went to MIT, and he has he's passed away now, but he had a degree in environmental engineering. He taught at Michigan State University, and he ran an engineering company for many years. And he was a well-known water expert, groundwater expert, water purification, water treatment. He did his doctoral thesis on removing radioactive strontium from water way back in the 50s, early 50s. So I kind of got in, say, water's in the blood, if you will. Anyway, I got into the bottled water business and discovered something called ionized water or alkaline water. It's got a lot of different names. It's got something, it's basically water produced by electrolysis. So I began to listen to, read about your book and then look at some of the, or listen to some of the interviews you've done so far, and it really struck a note with me. You've got some similarities here, and definitely almost like a foundation to build on what I know. And I don't have a scientific background per se, but certainly not formal. But it sounded like what you're doing could build, or add on to what I know about water and what it is. I guess the first thing I'd like to ask you is, a lot of people say, and I think with this is one hit out of the ballpark, water is water. And when I think, Bobby, you and I know water is not necessarily water, that there are many, many, many different types of water. But it's kind of a complicated question. What is water? Do we really know exactly what water is?
A long preface to a short but complicated question. Thanks. Well, yeah. This is a problem. We've all learned from childhood that water is H2O. We've also learned, I'll get back to that in a moment, we've also learned that water has three phases. It has a solid phase, ice, and a liquid phase, and a vapor phase as well. And what we discovered is actually it's not three phases, it's a fourth phase of water that we found. So, and this phase is interfacial, that is, it's in between, physically in between, between solids and liquids. If you, any water that comes right next to the solids, most solids, not all solids, but changes in character and forms this kind of a fourth phase of water. So that's the first point. Now, in answer to your question, this water is not H2O. It's actually different. If you look at the structure of this water, it's actually a kind of liquid crystalline structure. And if you add up the hydrogens and oxygens, it's not H2O. It's actually H3O2.
Okay.
And this actually gives it part of its character. So when someone says, "Oh, water is H2O, you can't do anything about it, no matter how you treat it, no matter what you do to it, it's just plain old H2O." Well, yeah. It ain't so. It has this component, this fourth phase in it. And depending on how much of this component is in it, the water can change its character immensely. Mm-hmm. So that's the point. You mentioned water is in the blood. Well, there's plenty of water in blood, and actually, if you look at the water in the blood, a lot of this water is fourth phase water. In fact, water in every cell in your body is mostly this organized, structured fourth phase water. It's not the kind of water that you find in a glass. So this finding, which is described in the book in great detail, but actually in a way that is accessible for non-experts, it was designed to be that way. It describes the fourth phase and the relevance of the fourth phase for health. Obviously, if your cells are filled with this stuff, it's very important for your health. Mm-hmm. And also, it appears everywhere. Wherever you have an interface of some sort, you have this kind of water. So we're talking about water in the ocean, water in clouds, water all over, water under the ground, water in contact with minerals. Fourth phase water forms in all of these cases. And if you don't really understand the properties of this kind of water, you can't really understand the properties of the material you're working with. There are lots of so-called anomalies of water. And there's a famous website that exists that describes anomalies of water. And what are anomalies? Well, anomalies are what actually doesn't really fit the current framework of understanding. Mm-hmm. You can't get the real understanding if you think there are three phases when actually there are four phases. So this fourth phase is actually really important for understanding what goes on in water and anything that water touches.
Right.
Okay. And it's described in the book, and the book, if anybody's interested, you can actually read a few chapters free if you go to the website Ebner and Sons, EBNERANDSONS, ebnerandsons.com. You can read a few chapters and see if the work is of interest to you.
Yeah.
Thanks.
Yeah. Okay. All right. So, very interesting. Now, again, I mean, there's so first of all, I guess we'd say, would you agree with the statement, water is the most important element for our health?
That's a tricky question. I'd say yes. I'd say, everybody knows we're 2/3 water, but the water molecule is so small that in order to make up that 2/3, since the molecule is so small, it turns out that you need so many of them that 99%, more than 99% of your molecules and my molecules are water molecules. So it's difficult to say that water molecules are unimportant to life when 99% of your molecules are water molecules.
Right.
Well, for those of your listeners who know about cell biology and have studied it, the 1,600 or 1,800 page cell biology book talks about every conceivable aspect of cell biology except water. Water. It's difficult to find water in the index. You find some reference to it, but mainly most people studying biology think that water is just a background carrier of the more important molecules of life. What are they? Well, we all know about DNA and RNA and proteins. They're the important molecules. The water is just the background carrier. It doesn't do a hell of a lot, just sits there. Well, that's simply not true.
Yeah.
It's not true for some of the reasons I just told you, that this fourth phase water is really what fills your cells. And the book I wrote 12 years ago, which somehow is making a resurgence, called Cells, Gels, and the Engines of Life, discusses the role of water in cells. And the basic bottom line is, if you can't understand how water interacts with everything else in the cell, there's no way of understanding how the cell operates. It's central to everything that the cell does. So you ask the question, well, is water the most important thing? It's hard to say what is the most important thing, but the water is central for everything we do.
Right, right. It's essentially involved in every metabolic process of the body, correct?
Absolutely.
Yeah.
And, if you think about not only our body, but if you think about plants, photosynthesis, the first step in photosynthesis is the water. The plant receives sunlight, and that light actually splits the water into positive and negative parts. That's the essence of the first step of photosynthesis. Of water is right at the heart of everything that happens in plants, and the same thing is true of us.
Now, let's get into the easy water. This is water that is ordered or structured.
Correct.
Give me the differences between the other states of water, in particular, I guess, the liquid state of regular water, conventional water, we'll call it, and the easy water, or this fourth state of water. How does it differ?
Sure, happy to do that. Well, the reason we call it easy, it's sort of easy to remember, but that's not it. Actually, it's because we call this exclusion zone. Now, why do we call it exclusion zone, easy? Is because the first thing we found out about it is that it has the kind of structure that excludes almost everything. So if you're dealing with this kind of water and you try to put solutes or particles or anything you like into it, as it forms, it just excludes, it expels everything that's in it. It's kind of like ice, when ice cubes form, if there are some impurities in the water, those impurities tend to get rejected. So the ice turns out to be pure crystals, pretty much free of all other stuff. This water is pretty much the same. In fact, the structure of this easy water, it's not ice, because ice is solid, but it's not unlike ice either. The chemical structure of this is rather similar to ice, but it's missing it's missing some protons, and that's basically the difference between this water and ice. So easy means exclusion zone because it excludes. That's why we give it this name. Another chemist with whom I just had lunch, by the way, he likes to call it polyhydroxide because, and I think it makes a lot of sense. We couldn't come up with a good name, but he came up with that name. Polyhydroxide, because the structure actually takes a lot of OH minus groups. The water can be split into OH minus and H plus. It takes those OH groups, and these groups are actually structured together. They cling together to give you this crystalline-like structure. So when you have this structure, you could easily call it poly, meaning many, hydroxide, meaning many hydroxides. But I think the important thing is that the structure of this stuff is a little bit like ice. And there are two more important issues. May I go on?
Yeah, absolutely.
Yeah, because unlike water, which is neutral, this stuff is negatively charged. So you have a negatively charged water, and when the water splits, what happens is these OH minus groups cling together somehow. That's described in the book exactly how this happens, forming this structure called the exclusion zone. And beyond that are protons, because the water is actually split into these OH minus groups and protons positive. So it's like a battery. You've got this exclusion zone water, which is negatively charged, and the H2O, which contains a lot of protons with it, that's positively charged. So this battery-like structure exists. And the other important feature is that you need energy to build this. You can't you can't like charge a battery without energy. This is a battery. You need energy to do it.
Right.
It took us 3 years to figure out where the energy came from. And finally, the answer was so simple. It comes from light. It comes from the sun. You put the sun onto it, or you put a lamp onto it,
Yeah.
and there you go. You build this thing like crazy.
Yeah.
Especially infrared light. You
Right.
put the infrared light on, and this exclusion zone, this structured kind of water builds immensely.
Yeah. And let's be clear, are you really talking about infrared, or is it more specifically far infrared?
No, it's not really far infrared. It's, well, depending on the boundary between near and far.
Yeah.
So the visible spectrum goes from about 0.4 to 0.8 micrometers. Mm-hmm. And starting at 2 micrometers is fairly powerful. 3 micrometers is really powerful. That's in the infrared, really powerful for building this stuff. So you can shine a really weak infrared lamp with a wavelength 3 micrometers, not too far beyond the visible region. And this exclusion zone can grow within 5 minutes by a factor of 3 easily. Now, the beauty of this, go ahead. Well, the beauty of this is that infrared is all around us. You know, you think of an infrared lamp or a stove or something that's giving off infrared. But actually, if I were to turn off all the lights in my office and turn on an infrared camera, and pull the shade so it's dark, turn on that camera, I'd get beautiful images of everything around, because everything is emitting infrared energy. It's you might call it free energy. And it's all over. So the buildup of this sort of water battery that we call it, the buildup of this battery is actually free. It comes from free energy, literally free energy from the environment.
I see. Now, how does it compare? Have you compared it at all to for instance, a far infrared sauna? Have you ever seen that? Are you familiar with that in that wavelength?
Yeah, I don't know exactly what wavelengths are coming out of the sauna. Maybe you know. Perhaps you can inform me, because I'm not sure.
Yeah, well, you're about 0 to 1,000 microns. So I believe it would.
Maybe 1 to 1,000.
Yeah, 1 to 1,000. So
okay, it's a broad spectrum.
And I think they try to keep it way down on the lower end. But what it's supposed to be doing is mimicking, or reproducing the same. Infrared rays that we're getting from sunlight, because that's what warms you. Like for instance, you step into, on a very, very cold day, you step into the sunlight and you feel warm. Well, that's far infrared, hitting your body and feeling that warm. That's why, for instance, maybe a cold-blooded animal, an insect or a reptile would crawl out into the sun on a very cold day to warm itself, so that the far infrared actually hits it. So we're talking something very close, if not identical to that, right?
I think we are, yeah. You're right. You go out into the sun, and most of us feel pretty good when we walk, especially in Seattle, where in the wintertime it's pretty gloomy.
Yeah, right.
And we walk out in the sun, and then you see a bunch of smiles. If there's sun outside, you have a sunny day. And so you tend to feel good, and most of us think, well, you feel good because there's some psychological effect. But in fact, the sun's rays contain wavelengths up to about, well, I think I don't remember the far end, but certainly up to 10 or 15 or so micrometers, where the tail, where the energy tends to fall off. And these are the wavelengths that water absorbs the most. So any water absorbs 3 microns very, very strongly, and other wavelengths near that pretty strongly. And those are the very wavelengths that we find that build easy water. So when you walk out into the sun, what really happens, the reason you feel good, is that this energy soaks into your body, light energy, infrared energy, and it builds the exclusion zones, builds the water structure. And this water structure is absolutely essential for all function. So by building up this water to its natural levels, where you may feel slightly logy or tired, or your muscles ache, and you go into the sun and you suddenly feel good. And I think the reason is that it's building up this exclusion zone water up back to its natural level. Now, when you go into the sauna, it's really the same thing. This is generating infrared. Infrared penetrates your body, builds up this kind of interfacial, easy water.
Mhm.
And everybody feels better after they've been in there. You know, you don't particularly like the sweat and such, but you come out and you feel like a new person. And I
Right.
think the reason is exactly that. It's a real effect. It's a physical effect.
Mhm.
It's not a, there may be some psychological aspects, sure,
Right.
to it, but it's actually the energy that you're absorbing in your cells.
Mhm.
You know, light can penetrate pretty deeply. If, for example, if you darken the room, you shine a flashlight through the palm of your
Mhm.
hand, you can, if you're dark adapted, you can see
Mhm.
it coming through the other side. So
Sure.
some wavelengths penetrate pretty deeply.
Mm.
Even some infrared wavelengths can penetrate deeply. And so this deep penetration is really what builds up this water and makes you feel good, because it restores the water that you need for proper function.
Yeah, there's a term in far infrared when you get into these saunas, and it's called resonant absorption. And there's a lot of misunderstanding about it, but you know what it is really this resonant absorption. So when your cells, your body cells, begin to vibrate at the same frequency as the far infrared wave that's hitting them, then it begins to absorb water very efficiently and
Light.
absorb it. Yeah, light. I'm sorry, light
Yeah.
very efficiently, and then it releases, since it's now moving, and it begins to release toxins, or we say things that don't belong in the body. So this is the fact. So, but this is what you're looking for. This term, what we call resonant absorption.
Yes.
So, yeah, and I think it's
absolutely. It is very important.
Yeah.
You absorb the energy, build up these exclusion zone, and these toxins are excluded, so they come out. Absolutely.
Yeah. I mean, that explains it really perfectly.
Yeah.
Now, you mentioned, going back a little bit, you mentioned the water having a negative charge. Could you qualify that just a little bit? Are we talking about an ionic charge and negative charge, or are we talking about ORP, a negative charge oxidation reduction potential, measured in millivoltage? What is the charge?
Good question. We're talking about real charge. So it goes back to the basics. If you stick an electrode into any one of your cells, you measure a negative electrical potential. Typically, it's about 1/10 of a volt, 100 millivolts or so.
Mm-hmm.
There's a classical explanation for this. It's a complicated one. It has to do with membranes and pumps and channels and such. However, when we found that this water, this EZ water, had negative charge, things became clear, because you know, the cell is filled with water. It's filled with this negatively charged EZ water. So it doesn't take a rocket scientist to figure out that, you know, if your cell is packed with water and this water has negative charge, that, well, sure, the cell is going to have negative charge. So I think this is the reason, the main reason why cells are negatively charged. It also explains why if you stick the same electrode into a gel, and the inside of a cell is just like a gel, but the gel has no membrane around it, you still measure the same thing. You measure negative 1/10 of a volt or so. And it's really hard to argue if you have a cell, gel-like cell with a membrane, and you have a gel without a membrane. It's hard to argue that the membrane is responsible for the negative charge in the cell.
Yeah.
So there's a real negative charge we're talking about. And I think it's very important to maintain that negative charge. So if you maintain the water, it's almost the same as maintaining the negative charge. You're just building up the negatively charged water, and therefore you're building the negative charge. So,
right.
So we got a lot of real negative charge inside our body. And it's occurred to me in the past couple of months or so that, you know, maintaining negative charge really kind of makes sense. We think of ourselves as neutral, but you might not be neutral. I hate to use the term negative because you're not a negative guy, but but I think maybe it may be that you and I have net negative charge because our cells are negative. And even the extracellular tissues mostly consist of proteins that are negatively charged proteins, and the water that surrounds them are negatively charged. So basically, most of us, we're negatively charged water. And so when you just do the arithmetic and start adding up, then, you know, you get negative charge. So then you ask yourself, well, gee, you know, what about antioxidants? So what do oxidants do? You know, oxidants confer positivity. They take away the negativity. And so you don't want that. You want to keep healthy. So antioxidants work just fine because they prevent that. And I think that's why a simple explanation as to why the antioxidants work as they do.
Right. Yeah, I mean, 100% agree with you, and we just always want this negative environment, negative charge, and negative ion environment, and you know, maybe you could explain it a little clearer to me, but I've always said a negative ORP and a negative ion are kind of like cousins. And like, for instance, you know, it's another thing, you get kind of gloomy in the wintertime. It's because we've got this buildup of positive ions inside buildings, especially here in Michigan. It's freezing cold. We never open the window. So, you know, and of course, all the negative ions that are much lighter than the positive ions have been stripped out of the environment through all the leaves being gone from the trees and the winds coming through. And so there's this kind of dearth of them to begin with, and then we put ourselves in boxes in our houses. We build up positive charges. So it's a very unhealthy environment, and things that will make you feel better. Or you could buy a negative ion generator, or go take a shower. When you got movement of water, you've got these negative ions. You go near a waterfall or the crashing waves on the ocean, or just take a shower, you've got negative ions, and that seems to, you know, lighten us up and make us feel better. And once again, I think you've got exterior negative ions, and now we're talking as far as water and what's going inside the cell is negative as well. So we want to bathe ourselves in this negative ion environment. Am I said that right?
Brilliantly said. Absolutely. You're right on. And you know, I've been aware of the issue of negativity and positivity. You know, I come from a different background. My original background is actually engineering and electrical engineering, so charges and such come naturally, but I've kind of come full circle in realizing how important these charges are in virtually everything around us. We did some experiments to check that. You know, I mentioned to you that maintaining this water, maintaining the negative charge inside your cells is really, really critical. And if you have positive ions outside, that's actually going to detract from that. So we did some experiments where we actually generated, and we had a setup where we could look at these exclusion zones, experimental setup, and we exposed it to positive ions. And sure enough, the exclusion zone diminished in size when we did that. So I think the effect is that we're talking about, the effect of the positive ions, the negative effect of the positive ions. Actually does stem from the fact that it actually impairs the exclusion zones. The exclusion zones are negative. You add positivity to it, then you erode this exclusion zone water, and you need it. You absolutely need it for all function. So I think the effect that you're talking about, it really boils down to an effect on the water inside your cells. This stuff has a direct effect. Being in a closed room with lots of people talking and breathing out protons and such, it has a direct impairing effect on the exclusion zone water inside your cells. And I think that's probably the main reason why you don't feel good.
Right. And when you say breathing out positive ions, really, carbon dioxide's one example of that. And of course, that's what we're breathing out. And this is, you know.
The CO2 in water, carbonic acid, is full of protons.
Yeah.
We actually get rid of this positive. We have natural ways of getting rid of it. You know, the urine also has low pH, and so it's full of protons. So we pee out those protons. We breathe out those protons, and if you sweat has low pH, and you get rid of those protons. So I think the body is designed in such a way that it wants to preserve that negativity, and in so doing, it actively gets rid of that positive charge. It's not good for you.
Right. Well, and it's been my main argument about against drinking pop or soft drinks, because it's full of carbonic acid. It's just an extremely low pH, and of course it's made with purified water, so it doesn't take much to get that pH very low, and you get the pH down there below 3, honestly. But you're putting all these positive ions into your body. Now, one other thing I'd like to say is that it sounds to me like everything you're describing, of course, is what is found, you know, is found in nature everywhere we go, and it's what is what is found in raw fruits and vegetables, which is a negative charge, For instance, and when I say raw fruits and vegetables, I mean very fresh, and especially when you juice them, you're able to measure a slight negative ORP, and then I would assume you see a higher pH, and I would assume because you see an abundance of electrons, so which are all negatively charged. And once again, these are free radical scavengers. We got free radicals that are missing an electron, that are looking to grab onto an electron somewhere in the body. It ends up grabbing on maybe to some kind of a molecule or cell and damages perhaps the DNA. It's one of the causes of disease. It's one of, as we said, we're taking antioxidants. We want to get things that oxidize the body out of the body. It's one of the reasons I promote eating as much raw fruits and vegetables as possible, because they're negatively charged. Because when you cook a food, you're taking a negatively charged substance and you're turning it into a positive charged substance. You're getting rid of all the electrons. You're really going to acidify it because of that. It's going to go into the acid range. And of course, now you're consuming that cooked food and all these the positive charge, and you're accelerating the aging process. How does that work into all this?
Makes total sense. Yeah. It makes total sense to me. I heard, I went to a conference recently, and I heard some of the medical practitioners talking about juicing. I'd heard juicing before, but never quite made sense to me. And suddenly it struck. What are you doing when you're juicing? And we started juicing after this. Well, you're taking plant cells, right? Mm-hmm. And what you're doing is you're getting rid of the tough stuff that's difficult to digest and extracting the cells. Mm-hmm. And these cells are full of easy water, negatively charged easy water, and you're basically eating it right from the plant. So you're eating something practically living. Makes total sense. So you're getting all of that easy water from those plants, this negatively charged stuff, to contribute to the negativity of your body and helping to replace any of this easy water that's not up to par, building it up even beyond that for perfect function. Yeah. So sure, that's going to be good for your health. It makes total sense. Cooking it, absolutely, you destroy all of that. Yeah. So yeah. Take the raw food and just eat it.
There you go.
It. Makes a lot of sense to me.
I couldn't agree with you more. Absolutely.
Seems like we're in resonance and a lot of ideas.
Absolutely. And because once again, it's all about this negative charge. I actually tell people all the time, and I don't know if anybody else says it, but I say the most important term you can ever learn about health is the term ORP, oxidation reduction potential, because everything you put into your body either reduces oxidation and reduces the aging process, slows it down, or accelerates the aging process if it's in the positive. And people, of course, never heard of this. They don't know what a millivolt is, and they never heard of of ORP or oxidation reduction. But it's once I began to study ionized water, and again, I don't have a science background. My degree's in journalism, so I can write. But my father was a great chemist. He really was. But and he would have understood this very, very well. But
you got it by osmosis.
Yeah, I think so. Right. I picked up on it, and so I could just see that it just all makes sense that and so I've always said, now we go back to the ionized water, which is produced by electrolysis. It's got a lot of different names, but I kind of coined the term ionized water because you're technically ionizing the minerals in the water, but you're running the water over positive, negative electrodes, and then you're separating the water through a membrane. So all the positive charged ions go to one side and all the negatives goes to the other. So you're always producing the two waters at once, one very acid, one very alkaline. Well, we drink the alkaline one, intuitively, or let's just say people think, of course we need the positive, because we should be positive, but ironically it's the negative we need. But what you're doing with it, to ionize means to gain or lose an electron, so you're shifting the electrons. And concentrating them really over onto one side, and so in a sense you're really you're kind of concentrating what you find in nature. And again, you'll find that in raw fruits and vegetables. But here, I mean, if you fill up a glass of ionized water, you'll see it's fully oxygenated. It's full of bubbles. I mean, really tiny little bubbles. It's very cloudy. And that cloud will disappear within just within 30 seconds. That disappears. And that's when you immediately get this low negative charge. And then, of course, since it's so unstable and you're dealing with electrons, it disappears quite quickly, although that negative charge will stay in there, again, depending on the conditions, the container, the temperature of the water, and certain other factors. It'll stay there for up to 24 hours with the negative charge, slowly working its way back up. But I said, to me, what I saw when I saw ionized water, and when I first, and again, I got into this, way back in '96. Nobody that I knew how to explain it well at all, and they were just sort of selling the product, and they knew it was good for you, and it felt beneficial. But anyway, the light came on one day over my head. I said, ORP, oxidation. That's why it's so special. That's why this is so incredible, and that's what's going on. So, but this, again, what I always say is, it's mimicking what we find in nature, and of course it's quite enhanced. It's quite strong. So I think it'd be interesting to find a direct, do a study or begin to study this, more direct correlation between what you're studying, which is easy water, which when I first heard one of your interviews and read what was going on in your book, that I said, this is ionized water. This is what I've always said. This is a negative charge water. And here we are reproducing it here in a very strong way. And then, of course, I say consume it. And, certain times, of course, you don't drink it around mealtime and this sort of thing because it upsets digestion. But this is what we should be consuming, because we're consuming, it's identical to raw fruits and vegetables in every way. It has a negative charge, abundance of electrons, it's alkaline, and it even is because it's structured, and I can go into that in 1 second, it's very detoxifying, a little bit different. But other than that, it's identical to raw fruits and vegetables, in particular juice, other than there's no nutrients in it, so it's just water. And then I would like to talk about this structure of the structured water, because once again, we've always, by the way, the Russians have done a lot of work on this, and I think the Japanese have studied it. There is one PhD level book that's written about ionized water, so it's not just, a lot of people kind of dismiss it completely, but it's been studied, and it's published by Elsevier publishers, and again, very high level PhD book. But it talks about the structures of water too, and maybe a six-sided water molecule cluster. How the structure of easy water? How does that?
It's a six-sided. It's exactly the same. It's
wow.
Six-sided. It's a honeycomb. It's actually, as I said, it's built up of OH groups, but they're arranged in a way that's a little bit like ice. It's like a series of sheets stacked on one another, and each sheet is a honeycomb full of hexagons.
Mm-hmm.
And so it's pretty much the same as you're talking about. I just want to first say that a colleague of mine in Japan has been studying this stuff intensely. His name is Sanataka Shirahata. Mm-hmm. And he's published many papers on electrolyzed, ionized, whatever you call it, water, with many positive aspects shown. And he was telling me, I don't know this firsthand, but he was telling me that there were clinical studies done in Japan. Some people were highly skeptical, and as a result of the skepticism, clinical studies were undertaken, and the results seemed to be so impressive that right now, he told me that anybody in Japan who has any kind of gastrointestinal problem checks into a hospital, the first thing they do is give them ionized water. Yeah. And the insurance pays for it. And so apparently the Japanese are convinced that there's something going on there. Well, we produced this about 5 or 6 years ago in our experiment, before I even knew there was such a thing as ionized water that you could produce. A Russian colleague of mine came to Seattle into our laboratory, and we started doing some experiments, putting 2 platinum wires inside of water and putting like 10 volts or so on them. And we found that some kind of negatively charged water accumulated right near the negative electrode, and positively charged water near the positive electrode. And these retained their charge. We found we could pull out those electrodes and then check the blob of negatively charged water and the blob of positively charged water next to it, and they indeed had negative charge and positive charge. And the odd thing was that, you know, ordinarily you put a negative charge next to a positive charge, and all they want to do is combine, you know, like man and woman.
Yeah.
And they don't do that. They remain separated. And this was the puzzle. We found that those blobs remain separated, and we published this in a couple of papers in some scientific journals, showing that they remain separated, yet they retained opposite charge. And we came to the conclusion that the only way they could do this, if these charges were actually embedded in some matrix, like two sponges next to each other, one's positive, one's negative, and they couldn't combine with each other. And we checked that, and we found that in the negatively charged water, there was indeed some kind of structure. We could check that. So I think a possibility is that this electrolyzed negatively charged water is possibly, maybe, the same as easy water. We checked our measure of easy water in a couple of the machines that we have, and we couldn't confirm it, but those studies are still going on. So we're not sure, but there's definitely a negative charge, and your cells definitely like the negative charge. So it makes total sense to me, and agrees with the Japanese studies, that there's something going on there that looks like it ought to be beneficial.
Yeah. It's a medical device in Japan and in Korea. And both those places, official medical device. It's been applied, they've applied for it in Taiwan, and probably going to get it, and then the same in China. So all those countries are, in fact, China, I think, has accepted it as a medical device, and they're now certifying that, you know, if you produce these water ionizers. And of course, the magic of a water ionizer is that, you know, you were saying that it's easy to the two different negatively and positive charge ions didn't mix. They thought they would have. Well, I always found that curious too. I said, why don't they just mix together? But with a water ionizer, you have a membrane in most of the units, and so as you produce it, it's even easier to separate them.
Sure, it may be easier, but it's actually not necessary.
Well,
easier.
Now that's the thing. So now there's a guy in Taiwan, and it's actually where we buy our water ionizers, and he's probably done more research with water ionization and been more successful than anybody I know. One thing he did was water ionizers have electrolytic cells, so that you apply the positive and negative charges to, and then it has various size plates, 3, 5, 7 plates usually, and they're rectangular. So what he did, you know, so he's, you know, Chinese background, Asian minded, and he says, well, first of all, this is wrong. We don't want a box. We want a circle. You know, this is how nature flows. So it's the first thing he said. So he developed 2 round plates. So now he's got, I'm going to say, you know, he's got about an 8-inch cell. I say smaller than that. I'm going to say he's got about a 5-inch round plate, and he's got 2 of them. And you don't need any membrane with this. It's the only one that's ever been invented. And he's creating it just through a positive negative charge. It's only the plates are only coated on one side. You usually use titanium plates coated with platinum for the conductivity. But and then you coat both sides. So and then of course you need, to get the same results, you need about 5 plates that are going to be considerably larger than this one 5-inch round plate that only has 2 plates. It's only coated on one side. When I say coated, I mean it's titanium and then it's coated with platinum. So it's a tremendous reduction in cost production. But the other thing you don't get with it is any kind of scaling. That you don't get the positive scale. And that's one of the biggest problems with a water ionizer. Is that, you know, there's all these schemes that have been tried to develop by different manufacturers to get rid of the scaling on the plate, so that, you know, the water stays, you know, strong, and, you know, you don't get, you know, the water's coming in contact with the actual electrode and not with the minerals that's been deposited on the electrode. So at any rate, but that made a huge difference in, again, making this round plate. And yeah, you don't need a membrane. And he produced, you know, this water is just produced instantly. I mean, it's, you know, it comes right out of the tap immediately. So it's really quite extraordinary. And I've said, when I first discovered this, I said, my gosh, this is one of the most, this is one of the most incredible things I've ever seen. You know, I'm in my 50s, so that would right up with me was the walk on the moon. invention of the personal computer, you know, and all everything that's come from then, and ionized water. Just witnessing that, I said, this has got to be one of the most incredible things I've ever seen. Join us next time on Achieving Great Health for part 2 of my interview with Dr. Gerald Pollack, and see if easy water really is ionized water. This is part 2 of my interview with Dr. Gerald Pollack on the subject of easy water and how it relates to ionized water. Is it the same? Here is part 2. When you create ionized water, you're taking normal tap water, filtering it, and then running over positive negative electrodes and creating positive negative ions in the water. And you're transforming it instantly, and what you're doing is you're transforming it instantly into a very powerful antioxidant. And you know, you can adjust the pH. It's got different levels of power you can apply to it, so you can go from a pH which really is all controlled by the electrons in the water, because in pH is that measurement of positive negative ions in the water. So you're able to adjust it, but you're able to get a pH between 9.5 and 10, well, ideally, where you get this really low negative charge, anywhere from maybe 200 or 250 to maybe 300, 350, and you'll see that's again a very low negative charge. And you look at a raw fruit and vegetable, you'll see the same thing. If you juice that very quick, juice it and then measure that ORP very quickly, there's things in the liquid that will tend to interfere with the measurement, meaning that water's a little easier to measure because there's no buffers in there, but you'll see that has that negative charge. So again, I guess my premise and I always postulated that ionized water is found in nature, because everyone says it isn't. It's found in nature, and it's exactly like nature, and then again, that's what makes it so special and so unique, and the fact that it's structured, of course.
Well, I think you're onto something when it resembles nature. If you look at the water that comes from deep springs, for example, it has minerals in it, and it's also under pressure. But we found that pressure, if you take ordinary water with minerals in it, even without minerals, and you put pressure on, the pressure actually shifts the equilibrium from the ordinary bulk water to this easy water. And the reason it does that is easy water is denser than regular. So if you take something and put pressure on it, it likes to convert to the denser kind of constituent. We found experimentally that's true. So if you look at the water that comes from deep sources, which is under pressure and has minerals, it's going to contain a lot of easy water. And people who have made measurements, for example, of some of the waters, the healing waters that come from the famous places like Lourdes and such, I've seen some of the measurements done by some labs, and they actually show that they contain easy water. So when you say mimicking nature, I think it may mimic some of the best waters that we actually have in nature, the ones that are known to be good for healing.
Yeah.
The same is true actually of glacial melt.
Right.
Some of the, like the Hunza and people who take this water in high mountains that comes directly from glaciers. If you look at this water, I've looked at a few places in the world. I've done a bit of traveling. And when the water melts from a glacier, it's kind of greenish. I don't know if you've ever noticed that. Just beyond the melt portion, you have these rapidly running streams. And if you look into them, they kind of glow kind of greenish or turquoise. And as they run for some distance, they eventually turn dark and black and what have you. And the reason for that, I think, is that these waters contain easy water, and easy water fluoresces in that color. So when you have that water, you have the sun shining on it, and the light that's given off by this water should be in this kind of turquoise, color. And the reason that you get easy water from ice melt is that the ice is just like easy water. As I said, there's a very small difference between the two, and in fact, we showed in the book that I mentioned to you and in some papers that if you melt ice, the first thing you get is not water, you get easy water. So you go from ice to easy water to bulk water. And if you freeze water, same thing happens. You go from water to easy water and then to ice. It's a necessary step in between the two. But in terms of health and drinking, so if you take the glacial melt, it's got a lot of this easy water. Now, I don't know if people have tried to see how good this is for your health, but I think this is probably another of nature's ways, perhaps, of providing really good water for health. So whether it's the deep spring water, the glacial melt, or the ionized water that I'm talking about, actually several other people have been manufacturing different kinds of waters that they claim have enormous health benefits. Some people actually claiming that they can reverse pathologies. This needs to be studied. I think there hasn't been one central group that has studied comparatively all of these different waters that are touted to be good for your health. And I know that the ionized water has many studies. The other people have fewer studies, and I think it would be worthwhile for somebody to actually, we'd like to do that. In fact, if we could get the funds to do it. NIH is not often as forthcoming for those kinds of studies. That we'd like to do that, to take ionized water at different pHs, to take some of the other waters that have been produced by other people that claim huge health benefits, perhaps some of the spring water, and test comparatively how they deal with various health issues. Yeah, very important to do, I think.
Yeah, absolutely, and you're correct in saying that. You know, there's in my book in the back, I do have that bibliography, and I do mention that book I produced by Elsevier. But I have over, I think now, probably 40 or 50 studies, and there's many, many more. I mean, it was my third edition published over a year ago. So there's many more. People are looking at this. Of course, there's a tremendous amount of work that was done with this in Russia. This goes back as far as I can find 1904, but they studied it in the 30s, and then there's actually. And they studied it in the late 60s and in 69, and I put it in my book right in the beginning about where they did that in Russia. But they were trying to remove, interestingly, radiation from the body. They had tremendous radiation problems in Russia, and they were trying to use some foods for that, and there are some successful ones, but one of them was ionized water. And I don't know why, but I mean, I just imagine, I'm just guessing that it must have something to do with the charge in the water and the negative charge and what really radioactivity is when it enters the body, and how this somehow either negates it or manages to push it out.
I think it manages to push it out because if you drink the right kind of waters that build easy water. The easy water excludes everything, radioactive, non-radioactive. It doesn't matter. We found everything. We could test substances as low as molecular weight, about 100 or so, and they're all pretty much excluded. And below 100 is difficult to test, but I think a good possibility is that that's the mechanism behind that success that the Russians had doing that. Just you build up, it's like building up ice, but you're building up water that excludes various substances, so it's natural it goes out. Yeah,
and I don't think it was such a new thing. I don't think they really understood what was going on at the time, because it didn't continue, but they continued to use it. And there was always these stories about when they did do this back in the 30s, that the people that were involved with it and ended up drinking this water, lived very healthy, and there were stories about it, but there were more anecdotal. And of course the other thing is, this is all in Russian, so I mean, it's just like the Japanese have done a lot of studying on ionized water, but it's all in Japanese, and so who's going to spend the money to translate it?
You don't need the money now. Google will translate.
Yeah, right. Yeah.
So it's really easy. I just read some Russian stuff this morning that was translated. The Russians have done enormous amounts of work on water. I'm going to Russia next week to participate in a couple of meetings, and it's always a delight to go there, because the Russian scientists are mostly really open-minded and have done amazing experiments with water, many of which we really don't know about. We should know about it, because there's a wealth of information there.
Yeah, they really are. That's what they do. There's no entrepreneurial history over there. I mean, that's what so the Japanese kind of took the idea, and they are the ones that really commercialized ionizers. There's a doctor, actually, I think back in the mid '80s, that produced the first ones, and then it became very popular by the '90s, and it been very common in Japan to a certain degree. And then the Koreans picked it up, and later, the Chinese, really the Taiwanese picked it up, and that's been about it. There's nobody else really making these, but the Russians had done all the work on it, and I corresponded with somebody at one of the universities. I can't think of the name off the top of my head, but I asked them for studies and if they had anything, in English. This is when I first wrote my book, and I got a response, and they had some papers that they ended up sending me some, and but yeah, they've done by far the most amount of studying that I've seen on water, and they're very good at all that stuff, the Russians. I mean, they really have done tremendous work. I mean, I think the first work with negative ions back in the 19th century, I believe it was around 1850s or so, was done in Russia. That the discovery of negative ions and what the role they played and how they how they had the effects on the body. And I mean, there's a lot of anecdotal stuff coming back as far as the Greeks talking about how weather changes affected people, and they would notice that what they were describing was a lot of winds coming down, stripping out, which is essentially the negative ions out of the air, really caused a lot of trouble. People would get depressed, they wouldn't feel as well, there was a lot more sickness, and then other times, they felt like there was this buildup of what they called electricity in the atmosphere, and they felt better. So there's anecdotal evidence going back, but like I said, the Russians were the first ones to really study that.
The charge effects are incredibly important. You ask yourself, maybe you haven't asked yourself, but you look up and you see a cloud in the sky, and you ask yourself, why is that cloud actually sitting up in the sky? If you measure, the cloud is full of droplets, water droplets. You ask yourself, well, gee, if you add up all those water droplets, it's pretty heavy. Someone calculated that in a cumulonimbus cloud, those giant clouds that are responsible for the thunder showers and such, the weight of a cloud, if you add up all those water droplets, it turns out it's something like 15 million elephants. Instead of kilograms, elephants is a sort of a more tangible kind of number. So you ask the question, well, gee, if there are 15 million elephants sitting in that cloud, how come those elephants don't come down on your head or my head?
Right.
What keeps them up? And I think you were mentioning charge in the atmosphere, and I think charge is really probably the reason, because the Russians and others found out that the Earth is negatively charged. I'm not sure if you or listeners are aware of that, but it's well established that the surface of the Earth is negative. And so if you have something in the atmosphere that's also negative, like water in the clouds, the two repel each other, and there it's easy to keep those elephants up in the clouds. And I think that's the reason. And so what happens is that when it rains, is a time when the positive charge in the air begins to neutralize that negativity, and so the cloud comes down, 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 and as it comes down, then finally it tends to rain. We don't get rain from high clouds, we get rain from low clouds. Anyway, the point is that what you were making, that charge in the atmosphere, it's not only important for how you feel, whether you're depressed or happy, whatever, but it's also important for atmospheric conditions, and I think that hasn't been taken into account. Most people thinking about weather, they think about pressure and temperature. I think the most important variable is charge. Next book is going to deal with that.
Yeah, fantastic. I mean, absolutely. And it's funny, I was just about to mention the negative charge of the Earth before you said it.
Oh, you were?
And,
okay.
Yeah, and this what has been kind of called lately grounding, or just running around in your bare feet. And because you're getting that negative charge, and that's another thing that can, your body likes, because you become charged. There's bracelets you wear that actually put a negative charge into your body. They have them around your neck, you have them around your hand, and they're negatively charged. They grab they actually allow you to conduct electricity through the body, rather than if you touch something electrical with both hands, you'll basically electrocute yourself. It's a micro electrocution, but that's what's happening. Whereas one of these bands here will allow ions to travel more freely through the body. It's also what goes on with, they've got these ionic foot baths. I don't deal with them, and I've only used one a couple times myself, but they're just putting negative ions into the body. They're just an ionization process, and so you feel a lot better. There's some claims made about them that I don't go along with, but pulling all sorts of toxins out of the body. And honestly, it would. You and I have been talking, as you put negative ions in the body, things that are positively charged that don't belong in the body will tend to start coming out. It's just they kind of go a little bit too far with some of these claims, but it's the same principle. There's one other quick area here that I wanted to cover, and I just get your opinion on it. How, and I don't know if you've studied it, but how does easy water differ from purified water? And that means water that has been produced by distilled or reverse osmosis. Have you studied that at all? You see?
Well, we haven't studied specifically, but purified water is or pure water. We use that in many of our experiments. That's simply H2O.
Yeah.
Yeah, and the easy water is anything but H2O. It's H3O2. It's totally different. Every one of its physical and chemical properties differ from H2O. So when someone raises the flag and says, well, water can't really do anything because just H2O, no matter what you do to it, it's just completely wrong.
Yeah,
it's not correct.
Right. So we really don't find H2O in nature in the sense that like in the rain clouds, we don't see that.
Well, there's some. I don't want.
I mean, pure, and what I really mean, purified water, not just there's water, okay, but I mean, is it really pure water, or is it some of it the easy water, or
some of it's easy water? The droplets, the aerosol droplets that form the clouds, they're droplets that are 5 or 10 micrometers in size.
Right.
And the evidence that we have, again, also described in the book, shows that these droplets. It's not just water. It's actually a shell that contains EZ water, that negatively charged shell. And inside is regular H2O full of protons. And those protons inside, it's like having a ball, and the material of the ball is EZ water. And inside, you have a lot of water with charge. Those charges repel each other. They create pressure. And that's why the droplet is round, because that pressure is being exerted on the membrane. The membrane is EZ water.
Right.
I think that's what the droplets in the cloud look like. Also in the atmosphere, when you have a humid atmosphere, like if you live on the East Coast during the summertime, and you look at the air and the humidity feels awful, but also you can't see very far. The air looks pretty not clear. And the reason it looks not clear is it's filled with these little aerosol droplets, and these droplets scatter light. So if you're looking from point A to point B, you're actually looking through a lot of little droplets, and those droplets scatter the light. That's why everything looks fuzzy when it's humid out. So anyway, the cloud contains not just H2O by any means. It's much different from that.
Right. And I've always said that, we don't find pure chemical substances in nature in their gas or liquid forms, that they're always mixing up with something. It's just the nature of everything that, that it's gonna meld and come together. And
Good point.
Yeah, and it's one of the reasons why we don't find purified water out in nature. So many people told me through the years, drink purified water, which I think is 100% opposite of really ionized water when you start to look in its real pure form, because you got a gallon of distilled water and a gallon of ionized water. You'll find if you can really sit there and measure them, they're totally different from each other. The charge is different. The ORP is different. Of course, it's void of electrons. Everything. The structure of the water is there's a water out called penta water because it's 5-sided, and this 5-sided shape is not found in nature, and is very bad for the body and very harmful, and doesn't hydrate the body well at all, and actually leaves it dehydrated, which is anecdotally what many people have told me through the years, that I started drinking reverse osmosis or purified water, and I started having all sorts of. I went to the doctor. I was dehydrated. And how could that be? I drink a gallon every day. I spend money on this distiller and everything. I said, well, that's why it's not found in nature. So, okay, that shores up what I always have said about that. And going back one more time about the structure of the water and this layering. and I think I've heard that in one of your other one of the other talks or interviews you did on this. The water molecule clusters and those shapes, this easy water, it layers. Can you explain that a little bit?
Yeah, if you have a surface, whether it's a surface of some material or a surface of a molecule or something,
Mm-hmm.
these layers begin to build. So if you have let's say you have a particle that's suspended in the water, then this particle, think of it as a ball, a small ball, and just like onion layers will tend to build up around the periphery of this ball. Those onion layers, layer after layer, is the easy or easy water that builds. If you have a flat surface, then the layers build their sheets that build. So it doesn't really matter whether it's a flat surface or a curved surface or even an irregular surface.
Mm-hmm.
These sheets or layers will build up. And we found they can build quite far. The current view of most chemists is that water may actually form a structured entity of some sort.